right, guys. So 2 things. One is just a repeat, and the other one is an announcement to make sure that we are all aware. I remember saying this last week, but I know everybody slept over the weekend and I forget things just as much as anybody else. So number 32 on the answer sheet I pass out, absolutely 100% wrong. Just cross out the answer on number 32. That corrected work will be going up with my work a little bit later on today. So you will have access to all of my work for every single problem here. Second announcement has to do with when we actually take the final. Yes, sir. Oh, you asked for another one. I'm sorry. I'm sorry. All right, so when you come in to actually take your exam, this will be your first exam of the day on Wednesday, which is the first full day of finals. When IU sits for the final, they have 120 minutes. They have 2 solid hours for the same exam you guys are going to be taking. The only thing that's fair is you guys also get 2 hours. However, type only provides a 90-minute block. So on Wednesday, when you come in to take your exam, if you are not finished at the end of that 90 minutes, I will write a pass. You can come back during 5th period, since you'll already have your 5th period final finished, and I can give you the other half an hour at that point. Does that sound fair? Okay. So you get the 90 minutes during our regular time, and then I'll write you a pass to come back during 5th period to finish for up to 30 more minutes. I do have to hold you right to that 120-minute mark. But you guys get the exact same amount of time that IU gets on that final exam. There are 20 questions on your final exam. It is not 20 questions with A, B, C, D, E, F, G parts. It is just 20 questions. Now, is it possible that there could be a question that has more than one part to it as far as what you have to provide back in your response? Yes, but it's not A, B, C, D, E, F, G parts. They might say, what is this? And also this piece. So like on a quadratic question, I could say, what is the maximum height of a ball and when does it hit the ground? So that could all be part of the single question. It's not going to be what is the maximum height of the ball, when does it hit the ground, where is this? It's not 12 minutes. Let's do it. I will work through anything and everything off the review that you guys would like me to work on. 21, 2110 and 1B, 2110 and 1B. Let's start with 1B since I'm right here. I'm going to kind of go in order the way it is on the page. So 1B and then 10 and then 21, and then I'll open it back up and work through anything else you guys want to see. 1B, I would use U substitution here. Let U equal E to the 4x. Grab my answer key. So then I would have 2u squared plus u minus 1 equals 0. And now I can factor this. Needs to multiply to -2 and add it to 1. So that would be 2 and -1. So this will be 2u squared plus 2u minus u minus 1 equals 0. Factor this by grouping. So 2u minus 1. U plus 1 equals 0. So u is 1/2. U is -1. And then I have to resubstitute e to the 4x in the place of u. So e to the 4x equals 1/2. E to the 4x equals -1. And right off the bat, I know that this one's not positive. Because for exponentials, my domain is all real numbers, but my range is all positive numbers. So I can't get an output from an exponential function that is negative. If I rewrote this in log form, That'd be the natural log of -1. I can't have a negative argument. So I know I can throw that one out. I am gonna rewrite this one into log form because I still need to solve it for x. Don't leave it like this. We don't actually have an x equals equation yet. For the natural log of 1/2 equals 4x. And then I can divide both sides by 4. So my exact solution, x equals 1/4 natural log of 1/2 or natural log of 1/2 over 4. So here's my exact. And then if I pop that into my calculator, my approximate solution is -0.173. We're gonna go do number 10 next and then number 21.
Do we have to put X for?
So if you have an exact solution that is not pretty, not some whole number or nicely decimal, you should show both the exact and the approximate since you are allowed to calculate. You can. U substitution, when you have 3 terms, 2 of the terms have exponents. And it looks like you could rewrite one of the terms in terms of the second one. So like right here, if I let u be the square root of x, if I take that and square it, I would get this. Right here, e to the x, if I let that be u and then I square it, I would get e to the 2x. So if I can take that middle term, the one that looks less complicated but has an exponent with it, if I can take that one and square it and get another term. But I would say your first tip off is you're looking at 3 terms. And it starts to feel like you're looking at it and you're like, looks like a quadratic, but I'm confused. That's when you want to try to use your activity.
Then how would you like, is it the same thing for the?
For part D, yes, but I would have to use one little trick at the beginning of that one. And that is to multiply the entire thing through by e to the x. So if I multiply this entire equation through by e to the x, I'm going to eliminate this. So e to the x times e to the x would give me e to the 2x. Because remember, when I multiply like bases, I add their exponents. So x plus x would give me 2x. Looking at that same thing here, if I add these exponents, what's negative x plus x? 0. E to the 0 is 1, so that would just be 7. Equals 8. E to the x. And now I would use substitution on this one. I would let u be e to the x. But yeah. Number 10 is the next one we're going to go look at. There we go. Find the center and radius of the circle with this equation. Okay, so I'm going to do a couple things right off the bat. I'm going to group these 2 together because those are my x's. I'm going to group my y's together. And I'm going to add 2 to both sides. Remember, I'm trying to get this into the form of x minus h squared plus y minus k squared equals r squared, because that'll give me my center and my radius. So I have x squared minus 4x. I'm going to have to complete the square here, so I'm going to have to add something to this. Plus, same thing over here, I'm going to have to complete this square. Y squared plus 6y plus something so that I can factor it into a perfect square trinomial equals 3. If I'm adding something in this first parentheses, I have to add it to the other side. If I add something in the second set of parentheses, I also have to add that one to the other side. And then to complete the square, I want to come up with what is the value that I put on that line So that when I factor this, I get a perfect square. I get something times itself. So I'm gonna take this value right here. Cut it in half. And square it. And give me 4. So I have to add that over here also. How will this trinomial factor for me now? X minus 2 quantity squared. All right. I'm gonna do the middle one now. What do I need to put on the line? 9. Because I take this number right here, cut it in half. We always cut it in half and then square it. So how will this set of parentheses factor out? Y plus, multiplies to 9, adds to 6, y plus 3 squared equals, what happens when I add the other side? 5 plus, or sorry, 7 plus 9, 16. All right, once I have it in this form right here, my center will be HK, and my radius will be R. Remember, this over here is not R, that's R squared. So where is the center for this circle? 2, negative 3. And our radius will be what? Radius will be 4. But you getting the clear part? Number 21. So far enough. There we go. A pharmacist is to prepare 10 milliliters of special eardrops for a patient. The eardrop solution has a 6% active ingredient, but the pharmacist only has 2% and 8% solution in stock. How much of each type of solution should be used to fill the prescription? We're going to define our variables first. X equals the amount of the 2% solution. Y equals the amount of the 8% solution. Right, in total, trying to make 10 milliliters of this solution. So when he takes all of the drops that he puts from the 2% solution, plus all of the drops from the 8% solution, we should end up with 10 milliliters. Then for my second equation, we're talking about concentration here. So the concentration of the first solution, so how much active ingredient is actually here? I take the percentage times the amount, so 0.02 times X. Then I take the percentage, so 0.08 times the amount Y. What I want in the end is a 6% solution out of 10 milliliters. So we're figuring out how much active ingredient there actually is in each piece here. Second equation, the one that I have written in purple, we have all kinds of decimals going on here. So to get rid of those decimals, I'm going to multiply this entire equation by 100. So that I have 2x plus 8y equals 60. You guys want me to continue working this out, or do you want me to give you a moment to continue working it out on your own, and then we'll compare answers? Okay, I'll give you guys a couple of minutes to work on this on your own, and then we'll compare your answers for time. If you want a 6% solution and you have an 8 and a 2 to work with, which one do you think we're gonna need more of? I have a 6% and an 8% solution. I want to end up, sorry, I have an 8 and a 2, and I want to end up with a 6. Probably more of the 8, because the 2% solution is more diluted. I don't need to add as much of that to bring it down. When you solve this out, you should get, for your 8% solution, you should get that you need 20/3 or 6 2/3 milliliters. 20/3, and 6 2/3. If I see your work, I see exact solutions. So exact solutions are most important, and then if it's something absolutely gross, like, some of the problems on the front page, like if they're exact solutions, you know, log 5 minus 2 log 6 over something like that. Give an exact, or give an exact in the class. For something like 20/3 and 10/3, you're fine to do it like that. Yes, ma'am. If it is a single fractional term, like a 20/3 or something, you'd be fine to leave it like that. If you want to write it as a decimal as well, you're more than welcome to. You're never gonna go wrong if you have both your exact and your approximate there. So since you get to use calculators on the test, I would recommend anything that does not come out as a nice, pretty whole number answer that you give both of those, just that way you've got both cases covered. For 20 questions and 2 hours, you should have sufficient time for every single question, even to go back and check it. What else would you guys like to see, or do you want me to finish working through this one? 3B. All right, so 3B, the first thing I noticed about this one is that piece inside the parentheses looks like it should factor. Will it factor? Yes, what does it factor to? X plus 2 squared. All over 2. What kind of expression am I looking at here? What 3 letters does it start with? Starts with L or G. I'm looking at a log expression. What can I do with exponents if I have a log expression? Move them to the front, so I can bring this 2 down to the front, so that becomes 2, and it comes down first with a multiplier, 2 times log base 2 of x plus 2 all over 2. Now I can cancel the twos, and that is as simplified as I can get that. The log base 2 of x plus 2. Yep, can't do any more with it than that, because we don't have it equal to anything. So I have 2 to some power equals x plus 2.
Oh, if it was like addition, I would be like, the thing you can't do.
Yes, if that was a plus in between the 2 and the logs, then I could do 1 plus log something over 2. I could distribute with my division the same way I distribute with multiplication, but I couldn't just straight up cancel it. Yes.
So if the same way with eggs, if you would bring the exponents to the front and.
Not until I have a single base, but then yes. So right here, I have a base of 10 and a base of 10. What do I do, or first of all, what's happening between these two bases? Multiplication. What do I do with these exponents when my bases are the same and they're being multiplied? I'm gonna add those together. So I would have common log of 10 to the power of 8x plus 8 all over x plus 1. And then, yes, I can absolutely drop my power down front using my powers property. So 8x plus 8. Yes. This guy right here is just 1. So I'm just multiplying 8x plus 8 to 1. So that's just 8x plus 8. What do you notice about that numerator?
Oh, you can take something out.
Yes, what can I take out? 8. So I have 8 times x plus 1 over x plus 1. My x plus 1 is canceled. And all that work just to get to 8. 19e? Absolutely. Woo! I'm part exponent. Yay.
No.
Okay. I would not skip any problems on that.
I would start.
Now, is it okay to skip something and come back to it later? Absolutely. That's entirely okay. 19E. Okay. 19E. All right, first thing I'm gonna do, I'm just gonna try to chunk this down, because one of the things, guys, if you remember what I told you about a week and a half ago, final exams, a lot of the problems when you first look at them, you're like, what in the world? Take a first step. Figure out how to chunk things down. Think about if you're reading a very large, complicated text, you're just gonna chunk it down. Just like in your English class. All right. I would look just at the numerator for starters. And looking at the numerator, since both pieces are under the radical, I can multiply them together and give myself a single radical effect. So I would have the square root of 18, a to the 7th, b to the 4th, and then over the square root of 2a. On the outside, we've got that ugly cube root, but I'm ignoring that for right now. Can I simplify the square root of 2a at all? Need square root of 2a alone. Can I simplify the numerator that's underneath that radical? Yes. Let's go ahead and simplify that. Square root of 18, I can break that down to be what?
Isn't that how many pairs you can take out of it? Yeah, so.
I've got 9 times 2, square root of 9 is 3, so I can take a 3 out, and I have a 2 that has to stay underneath the radical. Yep, so I have 3 square root of 2. All right, now let's look at the A's. How many pairs can I take out?
2, 3. Yeah.
3 pairs. If I have 7 socks, how many pairs can I make? I can make 3 pairs. So A to the third, and then I'm gonna have one left over, right? And then how many pairs on the B's can I take out? Two pair, so B squared. All over square root of 2A. All underneath cube root. What can I do? Cancel the 2A's out. Yay! So that just made it look a whole lot prettier. I've got the cubed root of 3A cubed B squared. Can I simplify that at all? Yep, I can take an A out. Cube root. Can I do anything with the 3? 3 B squared.
Why does it want to say?
You can't do something times itself again, it doesn't get you. Remember, for a cubed root, it has to be something times itself again. So like I can do the cubed root of 8, because that's 2 times 2 times 2. I can do the cubed root of 27 or 64. But I can't do the cubed root of, I mean, I can do the cubed root of 1, but after that, the next thing I can do is the cubed root of until you see. Does that make sense? Okay. Yes, ma'am. Yeah. So 18, 9 times 2, and I've got it under my square root, and I can do the square root of 9. You said 6? Yeah. Okay, absolutely. We can go do number 6. Valentine is framing a family picture to give his mother for Christmas. Remember, this one had a typo on your page. It should have been 60 inches, not 30 inches, for him to make the frame with. He has 60 inches of wood to make the frame out of. It's a large picture with an area of 216 inches squared. For what width will the frame have an area of at least 216 square inches? Why does it have that at least? Doesn't he want it to be exactly 216?
It can be graded.
It can be greater than 216 and he can put a mat around the edge. But it has to be at least big enough to fit the picture, preferably larger. Yes, ma'am.
Okay, so like, looking at this now, do you like have to see where they're probably work? Could it just be like in the back?
You're gonna have to see work. Now I'll show you where the work has to come in, because if you show me your factoring work, that's gonna be a piece of it. Like I don't have to see a ton of work for your factoring, but there's more to it than just that, and I'll show you why. Because when you see words like at least or at most, what does that indicate? Any value under, over, or that exact same value. So we're gonna have to inequality. So area is equal to LW, which is greater than or equal to 216. I like that. What is our perimeter?
2L plus 2W.
2L plus 2W equals 60. Love it. So when I did my answer key, I used X's and Y's. There's absolutely nothing wrong with X's and Y's or L and W's. I kind of like using L and W's here. So we want to know for what widths. I'm going to solve this for L. I'm going to write the length in terms of the width. So 2L equals 60 minus 2W. And then I'm going to divide everybody by 2. So the length is equal to 30 minus W. I'm going to take this now. And it's going to take the place of the L here. So I have 30 minus W times W is greater than or equal to 216. I'm going to distribute with W. So 30W minus W squared is greater than or equal to 216. What kind of inequality am I looking at here? This is quadratic, something that I can factor, but if I'm going to factor it, I need one side to be a 0. I never want my quadratic term, my squared term to be a negative. If I leave my squared term a negative and I try to factor it using the skills and tools that we've learned, you're gonna end up with your signs backwards. So please make sure that your squared term is positive. So in order to accomplish that, I'm gonna add W squared to both sides. So that means I have to subtract 30W from both sides. Or you can minus 216 from both sides, but then you're gonna have to divide by a negative 1. Which is gonna make my sign flip. So let's see where we are here. What do I have over on the left?
W squared. Oh, that's right. Right, zero, right?
0 on the left. And on the right hand side, I have what?
W squared. Or plus 216.
Okay. So here's where I'm at. Pause for just a second before we back this. Is 0 the bigger thing or the smaller thing?
Right now, it's the biggest thing.
0 is the bigger thing, so I want W. Like this whole side over here, not just W, I want this whole side to come out to be a negative number, because that's the only way I get 0 as being the bigger thing, right? Let's factor this. Does anybody know what multiplies to a positive 216 but adds to a negative 30? Negative 12 and negative 18, so W minus 12. W minus 18. All right, so places where I need to see some work. I need to see this. I need to see this. I need to see this. So I'm fine with 3 steps here. You don't have to show me the subtracting part. And I'm fine if you just pop out your factors, because you guys do get a calculator to use on the exam. So if you are like guessing and checking with some values, since we know it's going to come out to have a leading coefficient of 1 here, once you find those 2 values, you can with that. Here's one other spot where I have to see work. When I multiply these 2 together, what kind of number do we get again? A negative number, because 0 is the bigger thing. Do you guys remember when we did sign charts for quadratic inequalities? I have to do a sign chart for this one. So I have a number line up at the top. Our factors are at 12 and 18. Is it recording? Could be. Let me double check that I told it to record. Yes, we are recording.
So if we don't do a sign chart, is it like wrong?
You're gonna have a hard time coming up with precise answers. And you won't have evidence to support why you gave the answer to today. Because your answer needs to be an interval, not just 2 values, but remember, we want it to be 216 or larger. So do you need to do a sign chart? Yeah, you need to do a sign chart. All right, so our factors are not X. W minus 12. W minus 18, and then I'm gonna have the results down here. And one more time, because I feel like it took me a while to wrap my head around this part too. Am I looking for a positive result or a negative result? Negative, why? Yeah, I want 0 is the bigger thing here. And I'm looking for my answer to be within an interval. Because he's not saying that I have to do one side that's exactly 12, the other side that's exactly 18. Could do that, and you would have a frame that perfectly fits the picture. But he'd kind of like it if it has a slightly larger area so that you can fit a map around it. If I pick out a number smaller than 12, give me an example of a number smaller than 12. 11. So if I substitute 11 in the place of W, 11 minus 12 would give me what type of number back? Negative. 11 minus 18 would give me what kind of number back? Negative again. Giving me a result that is what? Positive. Am I looking for a positive result here? Remember, I want 0 to be the bigger thing. I want negative right here. Give me a number in between 12 and 18. 15, 14, let's go with 15, it's the first one I heard. 15 minus 12 is positive, yep. 15 minus 18, negative. If I multiply a positive and a negative together, I get a negative result. Something bigger than 18, 20. 20 minus 12, positive. 20 minus 18, positive. For an overall result, when I multiply those, that would be positive. Where are my solutions at? Between 12 and 18. Do I want brackets or parentheses around them? Brackets, why?
It's for the
Jesus.
And because we have that or equal to on the 12. That's why I want my square brackets there. So for what widths? W is equal to between 12 and 18.
So it's like we find, okay, we have to go to you take points off if you don't use inequality sign. Cause I couldn't make this.
So you would need an inequality because it said at least.
So, and then after that, you find the two numbers, can you just put the two versions of brackets?
You need to show me how you know that.
The inequality sign.
But how do you know that that's where it is? Something else that you could do is test the values out. So you could show me that if you have a width of say 10, think about it, we've got a perimeter that has to be 60, right? So if I've got this side that's 10 and this side that's 10, what would the long sides have to be to give me a perimeter of 60? They'd have to be 20 each, right? 10 and 20, 10 and 20 would give me 60 all the way around. But if I multiply 10 and 20 together, what do I get? 200, which is too small. That's not a big enough area. I could try something in between 12 and 18. Say 15. That'd be 15 and 15. What do you get when you multiply 15 and 15 together? 225, right? That's at least 216, so that works. And then you could try something larger than 18. If this side was 20, this side would have to be 10. So you can either do a sign chart or you can test values in each of those intervals, which is what my sign chart is doing.
So just something, would you want to see something in the interval, something out the interval, or something without the interval?
So I would need to see all three cases, the same thing my sign chart is showing. So if my width is smaller than 12, what would that mean about this whole thing? Would that give me the area that I'm looking for? Show me something in the interval, you know, and then show me something that's larger than 18. So I need to see all three cases, the same three things that that sign chart will show. So you can either use a sign chart or you can test the values in those intervals and show me that the areas either are or are not larger than what I need. I probably have time for one more short one if it is very, very short. Which one? 12B. Okay, on 12D, this one I definitely have time for. I'm gonna square these binomials. So I would have 2x squared minus 12xz plus 9z squared minus, and then I have to put this inside parentheses because I'm subtracting everything that comes after it. 2x squared plus 12xz plus 9z squared all equal to negative 3xz. So I squared my binomials. I'm going to distribute the subtraction. What's going to happen when I distribute that subtraction and I start to simplify the numerator? 2x squareds are going to cancel. Will anything else cancel? The 9z squareds will cancel. And I'm going to end up with negative 24xz over negative 3xz. So my z's will cancel, my x's will cancel, and I have negative 24 over negative 3, which is 8.
Yeah.
Alright. Like I said, my work will be going up today, looking at how busy I've stayed in the morning, it'll probably be up by lunch, possibly earlier than that, but at least by lunch. I'll have it up. And I just need to have time to take pictures of all the weeks and one thing, one single PDF.
I need to remember every vote of word. I can't